Hello everyone, my name is Chu Yiwei. Today I will discussing some key concepts in the regression analysis. We will cover the historical origin, the difference between statistical and deterministic relationship, and clarify the important distinctions like the regression versus causations, regression versus correlations, and simple versus multiple regressions models. Let's get started. Now we come to the first, which is the historical origin of the term regressions. The term of regressions come from Sir Francis Galton work in the 19th century. He was studying the relationship between parents' height and their children's height. He found that very tall parents tend to have the children who are slightly shorter than them, while very short parents tend to have taller children moving closer to a average height. He called this regression toward the mean. Over time, the idea developed into regression analysis, which we now use in statistics to study relationship between variables. Now, let's talk about the statistical versus deterministic relationship. It has the two types of the relationship, which is the statistical and deterministic. The deterministic relationship means that one variable fully determines another, like how the area of a circle is always pi times the radius square. No exceptions, but in the real life, most of relationship are the statistical, meaning that while one variable influence another, there's still variations. For example, studying more generally lead to better grades, but other factors like stress, sleep, and difficulty of the exam also play a role. Next, we come to the regressions. We discuss first the regression versus causations. This is a big misconception. Regression shows the relationship between variables, but it does not prove causations. Let's say we find that the ice cream sales and drawing incidents are highly correlated. Does that mean eating ice cream cause drawing? Of course not. The real factor is the hot weather. People eat more ice cream and also go swimming more. To prove causations, we need to control the experiment or deeper analysis. Next, the regression versus correlations. How is the regression different from the correlations? The correlation simple measure how two variables move together. It tells us if they are related but does not predict anything. Regression goes further. It model the relationship and help us to predict outcome. For the example, correlations might show that advertising and sales move together, but regression can estimate how much the sales will increase if we spend an extra 1,000 on. Finally, let's talk about simple and multiple linear regression. Simple linear regression has one independent variable predicting a dependent variable, like using study hour to predict the test cost. The multi-linear regression include two or more independent variables. For example, using study hour and sleep duration to predict the test cost. These models are powerful tools for decision making in business, science, and many other fields. This is a quick look at the key regression concept. Regression is a powerful tool, but it's important to understand its limitation and how it's different from the correlation and causations. But also hope you all can find this helpful. Thanks for watching.